Hello, welcome to the video lecture series on Introduction to Computer Networks. This is part 3 of our lecture on the topic of wide area networks. So we will jump to the point from where we left off. All right, so leased lines. Leased lines we have already mentioned that are lines which customers can rent from the WAN providers to be able to connect two LANs which are on two different geographical locations. So WAN providers can have the leased lines in the form of three different cables. There is the DS0, which is of the slowest speed, that is 64 kilobits per second. Then there's DS1, which is alternatively also called T1, which is 1.54 megabits per second. And then there's also DS3, alternatively called T3, that is 43.7 megabits per second. So the different kinds of connections that could be leased are, the first concept that we need to learn is something that we call a trunk. So the trunk is actually the physical cabling link, which is a bundle of multiple wires, and they are connected at the same time as a single bundle. So the way that a WAN provider can set up leased lines, the first kind is what we call basic connection, basic leased line connection. And what it does is that it simply combines multiple slower speed. For example, the T1 trunks, it can combine multiple of the T1 cables into fat leased line cable, and customers can lease one of these connections from the WAN provider. In the second kind, we have the time division multiplexing leasing, which implies that the customers will actually rent a certain time segment of a much higher bandwidth cable. So this implies that, say, you have a T3 cable running between two sides of the WAN provider, and customer A can rent the first 5 seconds. Customer B will rent the second 5 seconds. Customer C will rent the third 5 seconds. And every 15 seconds, it may come back, or there could be other time segments which are available for rent for other customers. So in a basic lease line, we have multiple trunks which connect the WAN provider's switches, which are running from the central offices across the WAN provider's network. So a customer, let's say C, they have two offices, C1 and C2, in two different cities, and they can rent a single trunk from the WAN service provider and have the line leased as long as they keep on paying it. Alternatively, time division multiplexed lease works in slightly different way, that the link that runs across two central office switches with the WAN provider, it is of a much higher capacity. And then what it does is that these cable, the bandwidth is broken down into multiple time segments, which we call channels. So now, instead of leasing a whole cable, a customer, let's say customer C, if it wants to connect its two offices, C1 and C2, it will then request the WAN provider that, okay, I will lease a port on your switch and a channel on the T3 trunk. So whatever that is sent from the T3 port will be sent over to the trunk port 4, and then on the other end, anything that is received on channel 5 will be forwarded on to the customer port number 8 so that it reaches customer sees other office. Let's say, for example, customer A would like to connect A1 and A2, which are in two different locations. So it will now say that it will rent a customer port 1 on the central office 1 switch, and it will rent port number 3 in the other switch. And then it leases a channel which runs between a channel on the wire T3 trunk, which runs between the two switches with the WAN provider. So now customer A can use anything that is sent on channel 3, and the WAN provider will forward everything to the appropriate ports on the two ends. So what we have seen as an improvement in TDM is that instead of renting out individual cables, we can now use a much higher bandwidth cable between two endpoints and then rent out time slots for the single wire. So if you look at a much larger setup, let's say in this example we have multiple sites, 4 different LAN setups, and they are connected through WAN network to each other. So let's say customer A has 2 sites, A1 and A2, and we can say that the TDM switch 1, which is a time division multiplex switch, it will forward everything that is received on channel 3 to trunk 8, which means through here. And the TDM2 switch, anything that it receives on channel 3 will forward it on trunk 2, so here. So now what happens is that A1 can now connect through this single wire to A2, and the same wires could actually also allow other sites to connect by renting out the channels. So the more modern version of this WAN network is the packet switching, and this is where the links are pretty much the same as a time division multiplex link. That is, it's generally a much higher capacity. But however, instead of using a TDM switch, a packet switching network uses packet switches. And this is something that we say requires content awareness. That means that the packet switches, they actually need to read the header of the packets which it is receiving and then make the forwarding decisions. So whenever a customer sends in a packet, it needs to be queued just in case the trunk is busy, and whenever it is available, it will then use the link capacity and send it over. So the result is that it allows eventually more traffic to flow over the link, because not all the customers will be using the link at all at the same time, and also not all continuously. So we can use the same link to rent out to a much higher number of customers and use a queue to queue their packets whenever it's coming in, just in case the link is busy, and then send it over whenever it's free. So at a given time, the multiple frames from multiple different customers could be flowing through the wire from one end to the other, and whenever it reaches the other end, it can take a routing decision based on the headers which are available for the packets. So if you look at the common WAN protocols, the 2 common ones that we would like to cover, the first one is called the High Level Data Link Control, or HDLC protocol. And one of the primary objectives of the HDLC is to deliver encapsulated data to the receiver. So this means that it packs whatever packet that it receives from one of the customer sites, encapsulates it, and delivers it to the other end. One of the powerful features of HDLC is that it performs error detection through the use of the FCS field. This is the same as what we have seen for Ethernet LANs, and it checks the integrity of the fields which are there in the header and discards them in case anything is changed. On the other hand, the other protocol, the point-to-point protocol, it's used by TCP/IP networks and routers which are capable of supporting multiple protocols can implement or can run the PPP protocol. And in this case, what happens is that the WAN needs to have a bridge of the LAN side to the WAN side. So as it is carrying along a frame through the WAN part of the network, it uses the type field, which is a part of the PPP header that is attached to the packet. And it could be the type of the TCP packet that is encapsulated. For example, it could be a simple IP packet, it could be an AppleTalk packet, or like a Skype packet, etc. So whatever it is, it just includes it in the type, encapsulates it, and runs it through the WAN network. So we can see a simple setup of WAN protocols with two LANs here, and let's say LAN 1 and LAN 2, they are connected through the WAN, which is a complex network within itself. So the WAN part is running multiple of these protocols. We have the HDLC, the PPP. There's also another protocol called EO-MPLS, which is multi-protocol labeled switching. So all of these are wide area network protocols. One thing that should be noted here is this edge router in the LAN, which is also a part of the WAN, because this is the part where the LAN and the WAN is connected. So what happens and what is required is that this edge router needs to be able to encapsulate anything that is coming from the LAN part into a WAN protocol. So it, what we call de-encapsulate, so it removes the Ethernet LAN header and trailer, reads the IP address information so that it is able to find the destination address, and then it re-encapsulates. So what it does is that it uses the logic to know where the packet will be forwarded, and then adds the WAN specific headers and trailers so that it could be forwarded through the WAN. So once it reaches the edge router in LAN 2, it then again does the opposite. So it removes the WAN header and trailer, and then looks at the destination and finally encapsulates into an Ethernet header and trailer and sends it to the destination that is initially intended by A. So now, instead of having one different kind of protocol which runs over the whole network, now we have LAN protocols which are running in the LAN segment, and we have WAN protocols which are running in the WAN segment, and we have edge routers which basically discards headers and add headers so that each protocol can be converted into the other one so that the packet can successfully go through the WAN to the other LAN.